Welcome to ICL's The Bottom Line, Fast Fertilizer Facts, where we break down fertilizer practices, products, and cutting-edge agronomy techniques in 10 minutes or less. In each episode, we will deep dive into one topic, one product, or one practice, and end up where it matters most, the bottom line. Today, we're digging into phosphorus availability, understanding fixation, soil pH, and nutrient efficiency. We'll talk about how phosphorus gets trapped in the soil, why soil tests don't always tell the full story, and what we can do to improve phosphorus efficiency without simply applying more P. With us today from the ICL Growing Solutions team, we have Ricky Bass, Technical Sales Manager, who works closely with growers and retailers in the field. Great to have you here, Ricky.
Thank you for having me.
Of course. And we're also joined by Tony Donahoe, ICL agronomist and product lead, who helps connect soil science with practical field-ready solutions. Thanks so much for being here, Tony.
Thanks for having me, Britt.
Together, they'll help us break down phosphorus tie-up and share practical strategies, including pH management, to help growers get more out of their soil and their fertilizer inputs. Let's dive right into this. Why does phosphorus availability play such a foundational role at that early growth stage?
Well, Britt, I think the main thing that is important for everybody to understand is that phosphorus plays a key role in the development of the plant, especially early on. You know, we want to have that readily available in that early germination time frame when the seed's just starting to emerge up out of the ground. We want to get it up out of the ground, roots established underneath of it as quickly as possible. That way it can start the process of making food through photosynthesis and stuff, and really kind of get off to a really strong start during the growing season.
Yeah, exactly, Tony. I agree with you. Phosphorus is very immobile in soil, so it's very important to make sure you have available phosphorus from the beginning. And it's the most important product to have at the beginning of the plant stage. So, like I said, it sets the foundation for nutrient uptake. You've got to have that phosphorus available to the roots from the beginning.
So what is really happening within the soil?
So if you look at, the soil in general, it's just like a big chemistry experiment. There you got positive and negative cations. So phosphorus itself carries a -3 charge. So you got all the positive cations, whether it's calcium, nickel, other micronutrients in there. So when that phosphorus first gets introduced into the soil, again, it's derived from phos rock. It's mined out of the ground. There's a chemical process it goes through to make it a dry granular or even a liquid phosphorus type product. It wants to convert back to that rock. What ends up happening is during those exchanges, the positive and negatives, think about back to your 7th grade science classes, when you take a positive and negative charge, what does it do? It's attracted to each other. So it wants to come together, and because of that it gets tied up, and so it's not readily available. So it has to go through this whole mineralization process in order for it to be plant readily available in that orthophosphate form, so the plant can take it up more efficiently and not have to do that conversion within the plant. The more the plant has to work through that conversion process, converting from poly and ortho phosphate, then that's when the plant's expending so much energy where it should be focused on developing that root growth, taking up the necessary nutrients, and then just creating food through photosynthesis and things like that.
Great point, Tony. We hear the term fixed. Phosphorus is fixed in the soil. Basically, what that means is that's no longer available to the plants, and so we have to go to the extreme of trying to make what is available able to get to the roots. And it's very important. I had a guy tell me one time, you may have enough phosphorus for a plant to survive, but you won't have enough phosphorus for the plant to thrive. And that made a lot of sense to me.
Yeah, and I think you hit the nail on the head there, Ricky. I mean, it all goes back to our ability to make sure that we're nurturing that soil and doing the things that we need to do to feed the microbial colonies that are already there from a nutrient efficiency standpoint. So it's not just focusing only on the nutrients that are there. You know, as Ricky said, we may have enough in the soil to get that plant started, but we may not have enough to finish it out and for that crop to thrive. So we have to make sure that we're doing the necessary things to be able to get that soil healthy, to be able to allow those plants to thrive and meet their yield potentials.
Rather than simply applying more phosphorus, what are the most effective ways to improve the availability of P that we already have? And how important is soil pH in that equation?
Soil pH drives the whole engine. Basically, if you can get your soil pH in balance, it just helps everything else work so much more efficiently. Again, you know, talk about seventh grade science class. I mean, let's go back to the human body as well. I mean, you think about we're just one big chemistry experiment. So if anything is out of whack within our own body autonomy and things, you just think that the soil is complex, if not more complex than the human body. The same kind of principles start, and it all starts with the soil pH. You get that right. Again, it drives the nutrient efficiencies and allows that plant to thrive to its genetic potential.
Yeah, and you know, just because you have a high phosphorus levels in the soil does not mean that that's available to the plant. So, you know, the soil samples may tell you that you have, you know, a high rate of phosphorus in the soil, but that pH is going to give you the optimum use of that product into the plant, and especially if it's available to the roots of the plant. Crop demand, root depth, soil conditions all matter when it comes to phosphorus.
Yeah, and I think, Ricky, you kind of hit the nail on the head there. If you got a soil that's high in pH, you know, we've got solutions with our PeKacid, Nova PeKacid product, which is a very low pH product. That what that does is help. You know, if you think of the positive and the negative, so you've got an extremely high pH soil, and you got the low pH product. You know, it just helps to start to kind of create neutrality within the soil. Again, helping drive nutrients into the plant and being able to kind of get that microbial colonies kick-started to be able to help solubilize the P that you have in the soil to be able to be readily available at orthophosphate form for the plant to take it up more efficiently.
I like our challenge, our 832.5. It's our potassium tripolyphosphate. It's readily available. It has zinc in it, along with some humic acid. I've worked with this product for years, and time again, it's definitely outperformed any other starter that I've seen that growers have used. It accelerates growth. It promotes that root growth from the very beginning, but we've had really good luck with that at the beginning.
Yeah, I would agree. Our challenge product, 832.5 with the triphosphate, is just a phenomenal product. And if you think of the tri aspect of it, most of your low salt starters are either 100% orthophosphates or they're an 80-20, 50-50 orthophosphate product. And so with the challenge product, it just, again, it's more readily available for the plant. We also have our Nova product, the 417.4 with 0.75 zinc in it as well. Neutral pH product, just another really high quality product to be able to use as a starter as well in conjunction with the 832.5 challenge product.
Yeah, Tony, another one is our BIOZ Diamond. It's a combination of molasses and yeast, and it really drives the microbials in that root in the soil to help everything available.
Yeah, Ricky, the BIOZ Diamond product is a great add-in product. It is a great carbon-based nutritional product to be able to feed those microbial colonies in the soil profile the way they are. Again, with the molasses, you kind of get that quick carbohydrate that your fast consumers will be able to come in. And then you also have the slower released with the yeast extract and things like that. That some of our slower consumers of the carbon-based nutritionals in the soil will have time to be able to feed and still continue to work within the soil profile. Just a great, phenomenal product in terms of being that carbon-based nutritional to feed those microbes that help drive nutrient efficiency into the plant.
That's the bottom line. Thanks so much, Ricky and Tony, for breaking that down for us today.
Thank you.
Thanks, Britt.
To learn more, visit icl-growing solutions.us or reach out to your local ICL expert.